Hey there, welcome to our channel. Let's continue with our episode. In the previous episode, we have seen why Elasticsearch is necessary and what kind of problem it is getting solved by integration of the Elasticsearch. That's a really very interesting feature for e-commerce application. So today in this episode, we're going to put our hands on integration of Elasticsearch. So we will integrate our Elasticsearch with the help of event-driven architecture. So throughout of this series, we have covered many interesting topics. So this is also another interesting topic which is going to give you a little bit understanding of why event-driven architecture are necessary in some cases, right? Alright, so why event-driven architecture is really useful. So event-driven architecture is super useful, especially when you are building some system that it needs to be scalable, responsive, and loosely coupled, right? So that means while we are going to create our products, if you go here inside this catalog service, go to API and go to our catalog routes, you can see where we are creating our products, right? So right after here, right after all of the validation, then we are creating our products. So once we are calling this create product function, right, then what it is going to do, it is going to create one record in our database. As soon as the database record has been created, then we need to return some feedback to our client, right? Right after this, what we need to do, we need to simultaneously create one record in Elasticsearch as well as. So which is potentially we are going to do with the help of event-driven, right? So how event-driven architecture is going to work? So in order to decouple our Elasticsearch integration with our catalog service, what we are going to do, we are going to emit some kind of events, right? We're going to fire some kind of events right here. Then down the line in the Express app here, we are going to put some kind of listener right here. So that means listener will be completely decoupled with the catalog service, right? From here, from here, right? So then once the product will be created, then the event will be raised from here with the help of some kind of asynchronous event, right? So that means we no need to wait for create the data in the Elasticsearch. You can go ahead and create that particular thing with the help of await also with the help of some kind of synchronous call, but that is always not recommended while you are our Elasticsearch is not primarily it's going to be a kind of source of truth, right? Now we know like while we are storing the data, then definitely we need to wait for store the data. That's why we are just like using synchronous call right here just to wait for complete that particular operation. Then we are going to give the feedback. But while we are going to write the data in Elasticsearch, we no need to wait for that because the event-driven architecture is always going to be very helpful. While it comes to we just try to loosely decouple like all of this stuff, or service, modules, or any kind of features as well. We are performing certain subtasks, right? As an example, as a part of our operation of the create product. Parallelly, we just wanna perform certain other operations as well as, right? So which is maybe it's going to happen asynchronous way. And it may be heavy work, right? But we are not waiting for that heavy work to be complete. Then only we are going to give the response to the user. So this kind of, while you are having this kind of scenarios, then definitely you can just like, use this event-driven architecture. As an example, while we are just creating the product, maybe we need to notify to the vendor. It's gonna say, hey, we have created this product. This is your email, or this is your any kind of like SKU ID or something else. So those data, we can just send it through, maybe we need to perform one email or send a message or anything. So this kind of side task or subtask, you can perform always with the help of asynchronous process, with the help of, you can say, event-driven way, right? So here inside this catalog service, go to utils, right? Here we are going to create one file. This is going to be Elasticsearch listener .ts, right? So this is the file name, which is we are just keeping to keep listen the Elasticsearch events, right? So here I'm going to write a couple of codes very quickly. Perfect. So now we have added some codes here. You can see we have imported the events, right? Events is a kind of core module of the node.js, which is going to help us out to perform the event-driven the operations, right? And we have imported the event emitter where we have just declared one class, right? And you can see the class name is app event listener. Maybe what we can say, we are just going to keep the same name for the file name as well as instead of this Elasticsearch listener, right? This is going to be perfectly fine, right? Because maybe we are going to use the event listener for some other purpose as well as, all right? So that's why we're just keeping like that way. But it's completely up to you, whatever name you are going to keep for this whole class, right? So now you can see inside this class, we are we are extending this event emitter from here, right? That means like our app listener will be inherit all of the property from our events, right? So with the help of the event emitter. Now we have just created this whole class as a kind of like, you can say, singleton, because we don't wanna they create multiple instances of this whole application. That's why we just like declare such a way. So we are just making this make sure this app event listener has to be only one instance throughout of the whole application process, right? That is what we are defining here as a singleton. And while it comes to singleton, then definitely what we need to do, we need to make sure like this instance, it has already created first, right? Or if it is already created, right? This is the piece of code which is going to make sure like it's going to always create first. Then if it is already created, then do not create a new one, just return it, right? So that is what we are doing right here. That means while we are just going to create this app listener dot get dot instance, then we'll be going to create the existing the app instance from here always. Then this is a constructor. This is like a normal call, you can see, right? And event name, we have added one thing, right? So this is called, while we are going to fire this particular events from anywhere, as an example, while we'll be going to notify our application is gonna say notify any kind of payload, or this payload we have declared here, that is called interface payload, where these are the only events we are going to accept: create, update, and delete product, right? Maybe you can add whatever the relevant operations, then you can add it right there, right? So this is the way it's really very helpful to make sure like your event is always like tightly typed in terms of like only create, update, and delete only going to accept. And as soon as we are notified, as soon as we are going to call this one, right, or notifying from anywhere, this means it is going to trigger our event process, right, by emitting certain event name. This event name exactly it says Elasticsearch event, right? It can be anything. It's based on your requirement, you can put any name. Then while we're going to emit this event, then we will be going to pass some kind of data also. This data exactly coming from the payload. And inside this payload, you can see we have subcategories also, which is called events, right? So that means while we're going to emit this is a kind of this particular event, Elasticsearch event is going to occur, then inside the payload also we can compare like what kind of the sub events are getting occur. Event can be create product, then perform the create product operation. Event will be the update product, then update product operation. Why this event name is necessary? You can keep this event name just to segregate, like if you have a different emitter which is performing certain different type of operations with the help of event-driven architecture, then it can be easily identified this event belongs to this particular event name. So that's why you can add it right there. So this listen function is going to help us out to read any kind of events data to perform certain operations in asynchronously. So let's try to go ahead and close this file and try to create one more class which is going to help us out to integrate our Elasticsearch. So in this case, let's go here inside the services, right? So we have right now our Booker service, catalog service. Let's try to create one more service. It's going to be, we can say Elasticsearch service. Here inside the file, let's try to add some code quickly. Then we'll be going to walk through all of the codes line by line. Perfect. So now we have added some code right here. You can see we have one class that's called Elasticsearch service, and we have created one index. That is, we are going to come back very soon. And we have one empty constructor. We are going to add some code right here as well as. But most importantly, you can see we have one function that is called handle event, right? And handle events is receiving one parameter that's called like, some kind of inputs. And those inputs is a form of event payload. You might have remember like this event payload we have just created in our listener. Can you see here, right? And this event payload can be what kind of like, events will be. Create product, update, and delete product. And those are the things we have added right here in the create, update, and delete. So as soon as this handle event is going to be triggered, then based on that particular event, then we can check like where this function has to go and what kind of operation has to be performed. So all of these things we are going to write it down right there, right? So right before onboarding all of this Elasticsearch code, let's try to integrate our app listener right here so we can just test it out. Our event-driven mechanism is working correctly. So here inside this app listener class, we can see one function we have that is called listen, right? So here as a kind of instance, we are using any. So what we are going to do, let's try to rename to something else. As an example, Elasticsearch instance, right? And instead of any, we are going to use our Elasticsearch service. Perfect. So Elasticsearch service is imported on the top right here. And right now, while we are going to receive this event from here, once we are going to be able to listen this function, right, by using this app listener, then what we are going to do, we will be going to pass this this particular function to our handle events by simply like this, right? So now our handle event is receiving this payload. This is a payload, is a form of our event payload, right? And as soon as you are receiving this particular trigger from there, then we can perform the create, update, and delete operations from. Now this is perfect. Now let's go to our Express app. We are going to create a couple of things right here as well as. So here, right after our Express app, right before maybe logger, this is going to be really very helpful. So here in this Express app, let's try to add something right there, right? So here, what we are going to do, we'll be going to say const Elasticsearch. Elasticsearch instance will be our new Elasticsearch service, right? This is going to be our Elasticsearch. Maybe we can say Elasticsearch service, right? Instead of saying instance, Elasticsearch service, right? Then we can say app listener, right? App listener will be dot instance, then listen, right? Here, what we are going to do, we will be going to listen to our Elasticsearch, right? Then we'll be simply going to pass our Elasticsearch service right here. Perfect. So now can you see? Now our application is integrated with our listener, right? So that means like while any kind of events are going to be raised, then our app listener can handle this listen functions right there. And where we have just already created this Elasticsearch service here. So that means we have just created the instance and passing right here. And we no need to worry to anywhere to perform certain operations in asynchronously. So our listener is on the right place. So that means if any kind of events are raising by that particular name, then listener can handle that thing, right? And our Elasticsearch service can handle those kind of operations asynchronously. So right now we need to find a kind of perfect place where we can raise those events. So what will be our right place? If you go to here inside this API, go to our catalog routes, you can see here we are just creating our product. Let's go to our create product function. And as soon as we are evaluating any kind of like error right after created, if it is there are no any kind of error, then this is going to be a right place where we can raise that particular event. So anyway, our app event listener is a singleton, right? So that means we can raise the event directly from here. So let's try to do that one. Now let's try to add our listener here, right? So we are going to say app event listener dot instance, right? Then we can say notify. And inside this notify, we need to provide some kind of object. Then first of all, we'll be going to provide our event name. Event. Then event will be create product. Definitely, we are creating product right here. And what kind of data we are going to pass? Those data, whatever we have just responded from our create product data, those data we are going to pass it on, right? Then perfect. There are no any issues right here, right? So as soon as it is going to be created, then this event listener will be notified that it's going to be raise one events from here. It is not going to wait for any kind of response or maybe feedback, and it will going to respond the data back to our client. Cool. Then the similar way we can do the other stuff also, just like we can say, let's go ahead and create the app listener event notify update. And this is the same thing we are going to do from our delete product as well as, right? We can say response. Yeah, this is like in the try catch we have not added, but we can say similar, just like this update. Perfect. And this data, delete product, only we are just like sending the ID or data from here also. Cool. Now everything is hooked up, right? So we're going to erase all the events while we're going to create, update, and delete. All right. And one thing we need to handle that is called the get product. That is also we are going to handle very quickly as soon as we are going to put some code on our Elasticsearch integration. So let's try to spin our application here. We will see like how the application flow is going through. It is able to trigger the event and listener will be able to handle those events correctly or not. Let's try to check it out. All right. Then let's try to spin our application. So we are going to say yarn dev, right? Now let's go to our Postman. Here we're going to create one product. So we can see this is the endpoint that is called localhost 9001, right? So what we can say, let's try to clean out all of the logs so we can see clearly. Now let's try to create the product. Can you see? as soon as we have just created product, it says like event received. Event received is create product, right? So in data will be everything like, ID, name and all. And you can see Elasticsearch handle event create product. So where this the logs are coming from? If you see here, this event received, it is coming from our app event listener, right? So here you can see the event received. First of all, this call it's getting called, right? This listener is getting called. Then it is going to our where? It's going to our handle events. So if you see in a handle events, you can see like this is the particular logs we have just added right here as soon as we are receiving the events, right? This is the console log it's getting printed where we are having our event and data as well as. So this is the line it is getting printed, and this is the event. Event name is our create product, and these are our data, right? Which is this part of exactly this part of console log it's getting printed, and eventually it is pulling back to right here because it's matching the create product the event, and that's why it is performing like this line. So now we're sure like our events are emitting correctly, right? Our event-driven architecture is working correctly, right? We perfectly able to raise the event. We perfectly able to capture the event as well. Perfect. So now we can see our create product is working, right? So let's try to test it out rest of other endpoints as well as. So in this case, what we're going to do, we'll be going to call our update stock maybe, right? So this is going to be our patch call, and we can say product ID 3. So now let's try to verify like whether we have that particular call or not here. Inside this API, go to catalog routes, we have our patch. Yeah, we have that one, right? And if you go to click on the update product, then it is also getting called, yeah, update product event. So let's try to do that one. So in this case, product ID 3 and stock, let's say 100, right? Let's try to call that one. As soon as we are updating our products, then it is instantly getting prior all of the events as well. And in this case, let's try to delete the product as well as, let's say in this case, this is not going to be 8000, this is going to be our 9001. 9001 product, this is going to be 3, right? Let's try to delete it. Can you see? Product is got deleted right here, right? Perfect. So now our event-driven process is working well, right? So that means like, we can delete the product asynchronously, update and create the product asynchronously. There are no any issues. Perfect. So now we're going to add some code here in the Elasticsearch. So let's try to install the Elasticsearch library. So in this case, we are going to say yarn add Elasticsearch, right? Elasticsearch. So this is the library we are going to use. Cool. Now let's try to import our Elasticsearch here. Import client from Elasticsearch. Perfect. So inside this class, Elasticsearch service class, we'll be going to create one client also. This is going to be private client will be our client, right? Then we can say inside this constructor, we'll be going to connect our client also, right? So let's try to connect the client. This client will be new client and process.environment. Yeah, because we are going to use some kind of environment variable. And this will be our default port, which is we are going to use from our localhost. If we have not assigned any kind of environment variable, then it can pick it up from here as well. So this part we are going to handle it or quickly, right? Maybe we are going to add some URL. Let's go to our env file, and we can say here this is going to be our Elasticsearch URL. Yeah, perfect. So we need to make sure like this environment variable key has to be matched exactly right here as well as. Yeah, it's matched. Now, right after this handle event, let's try to create a couple of bunch of function. This is going to be, first of all, we can say async create index, right? Create index, right? So now let's try to understand what is create index. So here you can see we have kind of index name, right? So this is called product. So index is simply refer just like MongoDB documents, or maybe if you refer to SQL, right? Maybe you can say table name, right? So where we are going to keep whole bunch of data, or maybe a very kind of like classic example, just like MongoDB collection, right? Maybe user or product, whatever. So inside that product collection, we can have bunch of product documents. So that is what exactly refer index is referred to the Elasticsearch. So what we need to do, we need to confirm like the index is always created first, right before storing the data, right? So let's try to do that first. So in this case, let's try to, we will check like index is exist first. This is going to be our index exists. And we will say await this client, indices, right? Indices, we can say exists, and we can provide this index. Index will be our this index name, right? So this is going to potentially give us if any kind of indexes are exist right there by index this index name, then it will going to return the data, right? Or return true. Then we need to check like what we need to check. You can say like this is a kind of boolean. Then we need to check if we have, if no index exists, right? Then we need to create one. Perfect. So now we can know we don't have any indexer is exist, right? And if we don't have any indexes exist, right? Then what we need to do, we need to create one. Let's try to add some code quickly, then we can explain it together, right? So now we can see if we don't exist any kind of indexes right there, right? Then we're calling this one, this client indices, and we are saying that create the index, that is the index name exactly we have just like declared right here, index name. And inside the body, we need to provide all of this property with the help of mapping and the properties, right? And you can see the ID, why we are adding the ID type is a kind of keyword, right? Because while we are adding keyword like this, we are going to treat the our Elasticsearch is going to be treated as a kind of string that won't be analyzed or tokenized, right? So it is going to be used from exact match. That means we need to find that particular product by ID exact matching whatever we are going to assign it right there. And title, definitely title is going to be a full text source, and description also going to be a full text source, right? And these are pretty explanatory, price and the stock, right? These are not, we are not going to use any kind of for sourcing mechanism or anything. We are only interested on this two stuff, right? Maybe we can provide the category as well as, so feel free to go ahead and add the category, but in this case, what we need to do, if you can see in the product model, we don't have a category right now, right here. So maybe we need to change the structure of the product so we can find the categories by this one, the product by category as well as, then it can be possible, because while we are just creating the product, then we need to provide those category information also to the Elasticsearch, right? So that is it's a kind of homework for I'm leaving up to you. Just like right after this whole integration, maybe you will get a kind of very nice clue to resolve that thing also. Perfect. So now let's go ahead and onboard rest of other functions also. We can say async get product, and in this case we are going to say ID. ID will be our string, let's say, right? Definitely we need to provide, because this is we are using keyword, then it's going to consider as a kind of string, right? So we are not very much care about like what we are going to be we are going to pass it right here, because anyway from the Elasticsearch you can find it out. So what we are going to say, we are going to say const result. Result will be await this client, and we can say cut, right? And here we will be providing the index also. Index will be index name and ID. So while we need to find something from our Elasticsearch by ID, then we can pass it accordingly, right? Now let's try to return the result, body and the source, right? This is not going to be body. We can say a result.source. Perfect. Let's go ahead and create rest of our features. But right before created all of these things, let's go to our DTO and create one payload here. This is going to be our payload.dto.ts, right? So inside here, we'll be going to create a couple of stuff, right? This is going to be, first of all, we can say export type. Type will be our catalog product, and where, because while we will be creating our catalog product, right, in our Elasticsearch, then we need to explicitly provide the ID also. That's always going to be mandatory, right? Because you can, if you see here, while we'll be going to perform any kind of operations, just like create, update, and delete, then ID has to be mandatory. So that is the stuff we need to add it right here. So let's try to add accordingly. We can say ID. ID will be number, right? And rest of other stuff we can keep it partial, right? So which is we are making it optional, right? So in this case we can say, we'll be going to say create product request. That is already we have added in our product DTO here, right? Create product request. And right now, if you see in the catalog product, our ID will be always mandatory, rest of other stuff will be optional. Now let's add all of the functions quickly. So now we have added all of the required codes. So let's go ahead and explore together one by one. So first of all, what we're going to do, perfect. So now we have added all of the codes. Let's try to explore it together. So you can see we have just to create the index right here if there are no any kind of index or exist by this index name, right? And we gave all of the required properties here. And while we're getting the product, right, by if we need to source any kind of product by ID, then this is the way we can find it out. We're saying client get this index name and the ID, right? Definitely this ID we need to use as a kind of string, but what we can say number as well as, then here you need to convert this thing's ID to string. Perfect. So now as soon as we are getting the result, then result underscore source, all of the data it is going to returning back as a form of our product details. While we are creating the product, then you can see we are sending the product details from here. Whatever events we are going to receive, that event will be having the product required data. It has to be at least mandatory the ID. Rest of other product details are not very essential. And you can see we just creating this the documents right here. This document data, we are just providing this document, whatever input we are receiving as a form of data here, right? That is called catalog product. And update also gonna be similar, just like we're updating that particular document by looking at the index and the ID and the whatever the documents data we are providing there, right? And deleting data is it's pretty similar. We need to provide the index and need to provide that particular document ID, right? Finally, we have search product. So search product is going to help us out to find any kind of product by its title or description. It can be anything. As an example, we can say phone. If phone is exist in the title or maybe description, it can be find it out, right? So we are saying in the query is multi-match. So what is exactly multi-match it is, all right? So multi-match is going to source in the multiple fields. And as an example, in the title, description, you can maybe add the category as well as if it is needed category, let's say category, right? Or anything, whatever the fields are available where it can be, you can search you can perform that search, you can just assign it right here. And what is the fuzziness is auto. So fuzziness is really helpful. It's allow the fuzzy search in terms of like while you have a typo in your search. And a very simple example, if you're searching for phone, then maybe you have a typo. As an example, poem. All right, you just type like this way. Then if you're setting it to auto, then it can be sourced to that particular thing correctly for you, right? And finally, once we are having the source result, then we are returning all of the data by looking at the heat.source, right? So it can be returned like multiple results from there. Perfect. So now you understood how these things gonna work, right? So let's try to hook it up all of these things together. So first thing what we can say, on the time of the constructor, we are going to create the index also here. Then finally in the handle events, let's try to call all of the functions. As an example here, await, we can say this dot create product. Data as a create catalog products, right? And similar applies for await update product, right? Then delete, all right? We can say data as a string, delete product, data as a string, right? So what we can do right here, let's try to add this const, maybe ID. We can say data as catalog product, right? And inside this catalog product, we can directly deconstruct all of these things from here. You can say ID. Perfect. So now we can just pass it on this ID to here. But this is definitely going to complain. Then maybe we can change the signature from here. It's going to be number. Then here we need to change it like ID to. And similar applies for if anything is not complying, then go ahead and convert it accordingly. Perfect. So now we need to create one Docker image file, which is going to help us out to spin our Elasticsearch. Then we can just fire all of this event. So now our Elasticsearch service is ready to spin. But we don't have any Elasticsearch running in our local machine for a while. What we'll be going to do in the next lecture, we'll be going to prepare all of the microservices for deployment, where I'm going to show you how we can prepare our microservices for deployment. And we will move all of the Docker images to one dedicated Docker Compose file in the root directory, where we will accommodate our message broker, Kafka, and our database and our Elasticsearch as well as. Perfect. Then see you in the next episode where we will be going to wrap up this whole series. Thank you.